Welcome to the Stormsurf Videos Surf Forecast for the week starting Sunday, July 14th. I'm Mark Sponsler, and I'll be providing your presentation. We'll discuss short-term forecasts, like looking at the jet stream, surface level pressure, wave models, local wind swell potential. We'll also look at medium-term forecast, all dictated by the MJO, goes out 3 to 4 weeks, active phase, inactive phase, and then we'll go long-term, looking at the effects of either El Nino or La Nina on the potential for surf generation, and sometimes we'll even talk about the PDO, going out maybe 10 years or more. All right, let's get into it. First off, current conditions in the South Pacific. We're looking for anything that could potentially generate swell, and we're not really seeing it. A small gale off of southern end of South America, generating, 33, 34 foot seas, but all aimed at Chile and not in the California or Hawaii swell window. Another gale in the far southeast Pacific generating 20-foot seas. Those seas will decay to nothing by the time they reach up into California. And that's about it. In fact, you can see there are 20-foot seas south of New Zealand, all aimed at Antarctica. And that is sort of the pattern for the coming week. But let's get into the details. As usual, we started looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough. That is a push in the jet in the southern branch of the jet stream. This is the southern branch right here, pushing to the north. And we see that right here. That would help create a clockwise flow aloft. And clockwise flow in the southern hemisphere is a sign of low pressure. That also manifests itself down at the ocean surface. And if low pressure is strong enough, it generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a trough. Not much of one, though. What is that? 110 knot winds pushing north? Yeah, maybe. And it's in the Southern California swell window. Southern California, and Northern Cal for that matter as well. About 117 west. So if you had low pressure of any substantial magnitude here, you could get swell from it. But of more interest, we see a ridge. That is the opposite of trough. This is pushing hard to the south. That creates a counterclockwise flow, and that is the sign of high pressure, just basically shutting down any chance for swell development. So all we have is this in the upper atmosphere, this area right over here. There's also a trough under New Zealand. One would hope that it might push off to the east, but we're not particularly disposed to think that's going to happen. All right, let's put this in motion, see what happens. See the wind just pushing south here, continued troughing here in the southeast Pacific, but pretty light. I mean, what is this? Yeah, 100 knot winds, a little bit more, maybe favorable for some light gale development, but probably not enough to make any difference. And here we're already into Thursday, and there's no real sign of a pattern change. Yeah, maybe a little bit of a trough trying to get push out here off of New Zealand, but notice all the winds just pushing hard south here, moving in the exact wrong direction. We get into Friday, same thing. In fact, it almost looks like the ridge is going to start rebuilding under New Zealand, and there we go. It does as we get into Saturday, and we'll just roll this on out, and then we're into Sunday, and basically we have a ridge over the entirety of the South Pacific. Not good for swell production, at least looking at the upper level charts. And we suspect that the reason this is happening has to do with the MJO, and we'll get into that in just a little bit. So let's go take a look down at the surface. All right, we expect that there should be low pressure here, and in fact there is not much of a low. What is that, about a 978 millibar low or something? 30 knot winds, 35 knot winds pushing to the north. You know, but really to get a swell that's going to make the 5,000 mile travel from here up into California, you need 40 plus, preferably 45 knot winds. This isn't going to make the grade. And then we have low pressure under New Zealand, but all the wind you can see, look at the arrows, all aimed south, pushing in the wrong direction. You need a good amount of winds. I mean, this looks pretty good. It's over a pretty large fetch area, just not strong enough, pushing to the north. All right, put this into motion. You see that pattern kind of continues into Monday night. Here's your date up here in Tuesday. And the cutoff for the California swell window still in there. I mean, maybe this is good for maybe 14-second period swell. And the same thing is just going on as we get into Wednesday. South winds just pushing south of New Zealand. No obvious sign. The low moves out of even the Southern California swell window as we get into Thursday. High pressure takes over here. You can see a 1036 millibar high. That's a strong high pressure system. And just no real fetch of any interest. We're getting into Saturday here. Still nothing of any interest. Again, we know this would be the case just by looking at the jet stream. And again, the next week looking not particularly impressive. All right, let's go take a look at the effect of these winds on the ocean surface. But before we do that, we're going back a week. Sunday last week. At that point in time, there were two gales in play. One in the southeast Pacific, one under New Zealand. This one with the one under New Zealand with 30, 32, 34, 36, 37-foot seas. And this gale actually started small under New Zealand, traversed the entirety of the South Pacific, and a week ago it was on the edge of the Southern California swell window with 36-foot seas. Now, this swell is hitting California right now. Not particularly strong because this gale pretty much traveled from west to east, so most of the energy was going in this direction and not pushing up to the northeast towards California. But still, there's swell in the water. Small little waves, chest high, head high at select breaks. In Southern California, maybe doing even better. But it is this gale here a week ago that, if you watch this, it lifted due northeast with 36, up to 39-foot seas, 38, 39-foot seas, 18, exactly 1 week ago. This swell is hitting Hawaii right now. And if you go look at the buoys, look whatever, solid swell, 4 feet at like 17, 18 seconds, hitting the south shore of Oahu now. That swell is bound for California. And the good news is a good chunk of that is unshadowed by Tahiti and the islands here. So that would mean more waves in a set and larger size and better consistency. All right. And so this system, you can see it made it till about Monday, and then it faded out. And we're just going to zoom through all of last week, and you see this was the beginning of the end. Just no swell, no systems of any interest generated any seas of interest, and now we're at current time. We'll roll this into the future and just see. We don't really expect to see anything other than some, what do we got, 20, 22, 24-foot seas, 25-foot seas on the hairy edge of the Southern California swell window on Tuesday. And that's about as good as it's going to get. And then things just go to sleep in the South Pacific. Not very good. So we've had a great run. I mean, what have we had? Like 4 or 5 swells in a row. None of them huge, but none of them unrideable either. Also notice the ice line here. Back a month or two ago, it was down at 65. Now it's creeping up to 62. Winter is setting in fully in the South Pacific. And what happens is as the ice encroaches north, well, even if you have wind over the ice, you're not going to get swell. You have to have ice-free waters. So the area available for storms to get purchased, for their winds to get purchased on the ocean surface and start generating swell, gets smaller and smaller as you get later into the July, August sort of time frame. So as swell dies out, now it's going to be a while. I mean, relative to California, there'll be swell for the most part of the work week. But by the time we get to next weekend, probably not so much. We're looking for potential for wind swell. Right now, along the California coast, winds are northwest at 15 in pockets. That's not getting you any wind swell. And Hawaii, same thing. No real fetch east of the islands. We'll put this into motion. So we get into Monday, Tuesday, we'll say Tuesday morning, winds start picking up along the California coast. High pressure out here, 1030 millibar high. Heat low inland generates a gradient, a tightening of the isobars, and that creates northwest winds. We see that. Maybe some wind swell along exposed breaks as we get into Tuesday. Broader fetch of 15-knot winds getting ready to push towards Hawaii. Maybe some building east wind swell at that time. And then certainly more so as we get into Wednesday, building east wind swell for Hawaii, building northwest wind swell for California. Mainly, we'll say Point Conception northward for sure. And continuing into Thursday, up to 20-knot winds east of the Hawaiian Islands. That's good. high pressure holding at 1032 millibars. Fetch starts breaking up, it looks like, relative to Central California as we get into Thursday night and Friday. New little gradient builds off of North California on Friday, making for small wind swell down to maybe Monterey Bay, something like that. East fetch continues for the Hawaiian Islands. Same thing as we get into Saturday, building wind swell for California. Wind swell starting to fade out for Hawaii. Just looking at the models here. Notice low pressure in the Gulf of Alaska starts cutting out some of the high here. Still, we got more, 25 to 30 knot fetch as we get into Sunday off North California. So there could be some wind swell there. Fading east wind swell relative for Hawaii. So short of it, yes, wind swell potential for both Hawaii and California starting Tuesday or so and continuing through the week. That will at least make up for whatever lack of swell we have by the time we get into the weekend a week from now. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation? That's really what we're calling midterm. That's about 3, maybe 4 weeks out. And then El Nino or La Nina, that would be maybe up to a year out. And then we'll see what's happening. First off, looking for the presence of the active phase of the MJO. The active phase of the MJO, when it's in the West Pacific, can change the trade wind directions there, and that in turn can help feed energy to the jet stream in the southern hemisphere in the summer, and more strongly correlated to the northern hemisphere in the winter, and that in turn can help support gale formation. So, looking at winds, this is the East Pacific here, West Pacific here, here's the equator, the date line is right there. That is New Guinea. So we see winds. This is from the TAO buoy array, series of buoys strung across the equator. We see east winds, pretty strong, making it almost to a point south of Hawaii and then getting weak. Then we see actual west winds in the far West Pacific in what we call the Kelvin wave generation area. This area from 170 west, 5 degrees north and south of the equator, the whole way over to the far West Pacific, 135 east. You draw a box right there. And if you get west winds in there, well, of course, that helps feed the jet stream. Can also create a Kelvin wave. And if you get enough west winds or enough driven by the active phase of the MJO, so if you get successive active phases of the MJO with strong west winds, that can create successive Kelvin waves. And Kelvin waves are balls of warm water that eventually travel east, erupt off of Ecuador. And if they're strong enough and have enough velocity, can help usher in El Nino. All right, anomalies, differences from normal for this time of year. Are these winds strong? These east winds stronger or weaker than normal for this time of year? And basically, they're about normal. You normally get trades over here, and they're pretty brisk. But in the Kelvin wave generation area here, you see we have full-on west anomalies going on. This is a clear sign of the active phase of the MJO. Looking at winds the past 5 days, these are wind anomalies, differences from normal. There's South America, Central America there. This is the equator, 0 degrees, running right down there. Okay, there's New Guinea. There's the date line right there. So the Kelvin wave generation area is right in here. And on the 8th of July, we saw west anomalies. There's orange and the orange area and the arrows moving from west to east. Continuing on the 9th, the 10th, the 11th. We've had west winds for quite a few days here. Let's go look what the forecast is. So this is not only the forecast, but also tells you what's been going on since June, right? This is the whole planet on one chart. Date line runs right up the middle. And so the Pacific Ocean is from about 135 east to about 90 west from here to here. But the Kelvin wave generation area, that's the area we're most interested in. It's from about here to here. So you just go straight up the chart. You see back end of June, early July, we had west winds developing. They actually kind of retrograded, and they built on the, basically on the date line area, pretty strong, and they have retrograded almost to the West Pacific as of yesterday. And then as of today, that looks like about the end of it. Maybe another small pocket of west winds continuing even for the next week. This is the next 7 days. We also see some sign of east anomalies starting to develop in the far western Kelvin waves. So what's this mean? Well, that for sure was the active phase of the MJO. Looks like it's going to be fading out as we go through the week, and maybe the inactive phase right there starting to move into the West Pacific. That would probably not be favorable for storm development. And looking at the jet stream charts that we saw, that sort of makes sense. The jet stream is going to, as we get deeper into the week, the ridge is going to start building over the entire South Pacific and shutting things down. Now remember, the MJO, whether in the active or inactive state, lingers for about 3 or 4 weeks over the Pacific. This last active phase started, when was that? About the end of June, and we're by about 3 weeks into July, it'll all be over. So that's about right, 3 to 4 weeks each phase of the MJO. All right, so let's go look 2 weeks out. Now this is a different sort of chart. This is not winds, this is outgoing long wave radiation. Basically, that's a fancy word for cloud cover. Is there a lot of cloud cover? If you have the active phase of the MJO, it's basically like low pressure, and it moves from the West Pacific across the Pacific over a 3 to 4 week period. Well, right now we're not seeing much of anything. Neutral pattern. This orange means more sunlight reflectivity off the ocean surface, so maybe the building inactive phase. And this is the statistic model. It says, yeah, but 5 days out, that's going to be gone, and we just remain in a dead neutral pattern for the next 2 weeks. The dynamic model, though, paints a different picture. It says, yeah, they're about the same, but as we get about 6 to 10 days out, the inactive phase starts building over the West Pacific and continues up to 2 weeks out. That's probably more close to reality, we suspect. Another way of looking at the MJO, phase diagrams. So what's this chart mean? Okay, we have 2 charts. One's the statistic model, one's the dynamic model. Assume you're looking down on the North Pole, and the MJO travels from west to east, from the Indian Ocean over the maritime continent, across the Pacific, West Pacific to East Pacific, on the equator, so underneath the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Round and round it goes. All right, the heavy dot is where the active phase is today, so it's like in the far eastern Atlantic, maybe probably over North Africa. And this is and if it's inside this circle, it's considered extremely weak. If it's out here, it's considered stronger. So a very, very weak active phase of the MJO, pretty much on the other side of the planet from where we want it to be in the Pacific. And forecast to migrate east but remain weak for the next 2 weeks. Dynamic model, basically giving us a variation of the same thing, maybe a little bit stronger, but the active phase still at 2 weeks out, locked in the Indian Ocean, not in the Pacific Ocean. So far, all this data suggests that we're moving to the inactive phase of the MJO in the Pacific, hence the jet stream pushing south towards towards Antarctica, hence lack of storm development. The 40-day upper level model, so we're going out a little bit beyond a month now. All right, there's South America, there's New Guinea, there's the equator. Dateline is roughly around right in there. Kelvin wave generation area in there. The greens, areas favorable for precipitation. One would assume that means the active phase of the MJO. The yellows and oranges, inactive phase. But what you see is real no coherent pattern. If this was the active phase of the MJO, you'd want to see it slowly working its way across the Pacific over the length of this model. We're not seeing that. We're not seeing any inactive thing doing anything, just an extremely weak MJO signal for the next 40 days, according to this model. And yet one more model. This is the CFS model. All right, whole planet on one chart. Pacific, the Kelvin wave generation area between this tick mark here and here going up. The oranges and reds are westerly anomalies, synonymous with the active phase of the MJO. The heavy black line suggests a weak, it's kind of broken up, where up here, that's a real active phase of the MJO with heavy westerly anomalies. You see it supported tropical development. This was back in the early part of May. This was an inactive phase of the MJO. Now we're in a weak active phase. This is days past, strong pretty solid westerly anomalies. But here we are today, and the forecast. Now the good news is westerly anomalies are to continue on the dateline through August 11th, so that's basically a month out or so. We see easterly anomalies. They only make it to 150 east, so that's not even hardly in the Kelvin wave generation area, and then fading out. So we're not seeing any signs of the inactive phase of the MJO, but we're not seeing any robust active phase either. We're not seeing any strong signs of El Nino either. Just this, but this weak westerly wind pattern that is definitely suggestive of El Nino, but pretty weakly. Okay, one more model. And this is the same sort of chart, but it's reversed. Past stuff, past activity is down at the bottom. The forecast is moving forward. Yellows, oranges are westerly anomalies, Kelvin wave generation area right here. So you go up, you see we had a pretty strong active phase of the MJO. We're assuming based on the westerly wind event here back in May. And we saw that on the other chart. Here's our current active phase that's pretty weak. And looking forward, we see, weak westerly anomalies holding in the core of the Kelvin wave generation area, but not strong, not particularly defined. Let's overlay the MJO. Here we go. So here's our current active phase of the MJO, fading out over the dateline, maybe on the 20th of July. So what's that? Maybe 6 days out. The dotted contour is the inactive phase of the MJO, generating easterly anomalies over in the far west Kelvin wave generation area, but westerly anomalies hold, not so bad. And then we see another active phase, a little bit stronger one, starting, we'll say somewhere around mid-August or so and going into late September. So this would be a good target here if you're going on a surf trip, you're in the Pacific somewhere. This is when you would expect swell development, storm development, enhanced here by the active phase of the MJO. This area here during the inactive phase probably, if anything, suppresses storm development. Not a great time for swell production. Good time to take care of business. Work hard so that you can be available when you see this coming in the late August, September time frame. Okay, and one more thing, the low pass filter. Now here's the interesting part, this overlay. So this is basically, when you see the solid contour in the Pacific, it's a low pressure bias regardless. Solid contour, we had 1, 2, 3 contour lines. That was back in March. They're getting weaker and weaker. And here we are today with basically 1 contour line, and even that as we get to the end of August is to fade out. This is basically your El Nino signature. We've been in El Nino this past winter. Yeah, we got lots of precip in California. It was a weak El Nino though. Surf wasn't great, but there were moments, there were waves. But notice here, as we get into September, the low pressure bias shifts into, this is the Indian Ocean. At some point, we're almost expecting to see dotted contour right here, which would be a high pressure bias, start building in the Pacific on the dateline. And that would be the sign, notice like here, see that dotted contour in the Indian Ocean and the solid contour here? They flop position, and it looks like that switch is going to start happening in the fall. So the thought would be maybe we're moving towards a La Nina pattern. Now, just looking at this, we suspect it doesn't happen on a dime. It takes like 3 months to transition. So if this starts in, let's say, September 1st, September, October, November, maybe sometime around mid-December, it would start becoming noticeable in the atmosphere that, hey, the storms aren't quite as strong as they should be for this time of year. And then that suggests that probably maybe not as much precip into California either, not as much snow, so, and all this is dictated by El Nino. So you wonder why we spend so much time looking at the MJO. Well, the MJO helps feed El Nino, or lack of active MJO feeds La Nina. That's why we're doing this, because you can get a pretty good sense of what's going on long term and what might happen a season, 2, maybe even 3 seasons out if you follow this data. All right, let's move on. So El Nino is really characterized by the movement of warm water from the West Pacific to the East Pacific. So this is actual profile. This is the West Pacific here, East Pacific here. These are anchor lines on the TAO buoy arrays. The X's are sensors on those anchor lines. From that data, you can see subsurface temperature profile. And you use a little bit of modeling software to fill in the blanks, and you see warm water here in the West Pacific. This is holding about steady. That's 30 degrees centigrade. The 29 degree isotherm, It was at 160 last week. It's backtracked to 162. The 28 degree isotherm, it's holding steady at about 150. The 24 degree isotherm, so this was pushing into the Galapagos area here, maybe 2 weeks out. It is backtracking too. So when you see these lines starting to all push to the west, that suggests that temperatures are getting cooler in the east, and that's not good for El Nino. El Nino is all about warm water pushing east. When you see it backtracking, that suggests the demise of El Nino. Now, that said, let's look at anomalies, differences from normal for this time of year, because temperatures move around. All right, so we see, the good news is here, we see 1 degree above normal, 2 degrees above normal here in the West Pacific under the date line. Also another pocket of 2 degree anomalies here in the East Pacific. The entire equatorial Pacific is dominated by slightly warmer than normal water. That is a typical sign of El Nino, but if you're only talking about 1 or maybe 2 degrees in pockets, that's not a strong El Nino. The good news is, look at this. So we've had, 3 weeks of westerly anomalies, winds actually blowing or just slack trades in the West Pacific. So that allows warm water over the maritime continent to start bleeding into the Pacific Ocean. You see that here. It's almost like another Kelvin wave is trying to organize very weakly. And we had actually written this all off, but now it kind of seems like, well, maybe not quite. Maybe it's not over. So at least according to this model, the whole Pacific is full of warmer than normal water. But this other model here suggests, well, maybe not so much. It's limited to a small area. It's not really showing warm water pushing in from the west. It's just this one last little ball of warm water, mainly from previous westerly wind burst events, previous Kelvin waves, and decaying with cool water. This is probably the upwelling phase of the Kelvin wave cycle here, but cool water the whole way under this ball, suggesting, well, maybe this is the beginning of La Nina. It's hard to say. It's a mixed bag. Let's go take a look at some more data. Sea level anomalies. Okay, what's this mean? Okay, sea level anomalies. Is the sea higher or lower than normal? What do you mean? Okay, well, this is JSON-3 data. It's JSON-3 satellite. We use that for checking sea heights and storms a lot. But what you can also do is you can strip out all the waves, strip out the tides, and just see if the ocean, where the ocean is bulging. We see it's, and you're only interested on the equator because that's where Kelvin waves form. And this is all about, El Nino is all about Kelvin waves. We see a little bit, 0 to 5 centimeter above normal bump right here on the Kelvin wave. So that suggests, so if there's warm water at depth, warm water kind of expands, and that creates the bump on the ocean surface. We also see a negative anomalies here off of the Galapagos. So certainly no Kelvin wave there. This is probably the upwelling phase of the Kelvin wave cycle, and maybe just the faintest of Kelvin waves trying to organize under the date line. But otherwise, pretty neutral pattern, suggesting neither El Nino or La Nina. All right, this is our favorite chart because it puts it all in perspective. West Pacific here, East Pacific here, upper ocean heat anomalies, upper 300 meters of the ocean. So you can see clearly back even, this is August a year ago, even before that there was a Kelvin wave that came across warm water, upwelling phase of the Kelvin wave cycle. I think this was Kelvin wave number 2 here, went from west to east, driven by westerly anomalies, driven by the active phase of the MJO, eventually erupted out over towards the Galapagos area, upwelling phase of the Kelvin wave cycle. Kelvin wave number 3, I think this was, not as strong, not even making it to the East Pacific back in March of this year, and then upwelling phase of the Kelvin wave cycle. This new Kelvin wave here developed in June, very, very weak, and then it almost looks like, you can see, sort of follow the contours here, you get a sense. Almost looks like another Kelvin wave trying to organize, but so incredibly weak that it's probably not going to make much of a difference. And we've said this before. Look at the warm water in the west back a year ago, and there's no warm water there. Now it's negative anomalies. This just smells very much like the beginning of La Nina, but this existing El Nino is trying to hang on. The longer it hangs on, the better, because that means the deeper into fall and maybe winter we can go before the tables start turning on us and we move towards a La Nina pattern. What we've kind of been hinting at is, somewhere between Thanksgiving and Christmas, that's where the tide's going to turn. This supports that conclusion. All right, so let's take a look at sea surface temperatures, because it's really what's going on at the surface that then affects the atmosphere above it. And, if you get plenty of warm water building here, well, there is Peru there, Chile's down there, Ecuador right there. The main El Nino, the place we like looking for El Nino is this area right in here. Now, clearly, we're not seeing a whole bunch of warm water. Doesn't look like El Nino. If anything, temperatures here have been dropping steady and pretty dramatically the past 2 weeks. Still, there's pockets of warm water. There's also cold water upwelling occurring here along Peru. And the temperatures down here, at one point, this whole area down to 20 south was full of warmer than normal water. That's quickly retreating. It's like 10 degrees, and then even out in here it's fading. The main official El Nino monitoring region, 120 west, 10 degrees north and south, 5 degrees north and south of the equator, going out to 170 west. So draw a box in your mind, sort of like the Kelvin wave generation area, but off to the east. When you have warm water here, that's officially El Nino. But on strong El Ninos, this whole area here should be full of warm water. We're not seeing any of that. And when you're in La Nina, you see cold water moving into this area here. We're not seeing that either, but it's certainly not a building El Nino. This is the trend the past 7 days. This is not good. You see the blues? That's a cooling trend building even into the official El Nino monitoring region right here. 120 to 175 degrees north and south, and streaming the whole way off of Ecuador, indicative of easterly anomalies, at least, if not cold water upwelling from deep in the ocean. Okay, even if we have a Kelvin wave trying to develop here, doubtful it's going to make it the whole way over to here. It'll probably make it to about 120 and then 120 west and then just die. Now, looking off of Africa, a lot of times what we'll see, this will be the leading indicator over here. You'll see temperatures cooling here, and then it'll start building there. We see it warming over here, and I think last week it was actually warming. It was the week before that it was cool, but that has not translated into the Pacific yet, suggesting that maybe the Pacific is leading the change towards a cooler regime. At least that's our estimation. The backed off view here, okay, what's going on? This, that was a 7-day trend. There is those pockets of cool waters from the 7-day trend, right? Okay, but you see warming not so strong south of the equator. It's really, again, only 5 degrees north and south of the equator that we're interested in. Pretty good amount of warming out here in the central Pacific. Modoki El Nino is what they call that. When you get warming, but it doesn't make it the whole way off to the east and just kind of sits out here. It's like an El Nino, but not really. And that's kind of where we are right now. All right, so let's look at the atmosphere. There's warm water on the equator, not particularly strong, but is it having any effect on the atmosphere? Okay, one way to measure that is this index, the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. When you have lower pressure over Tahiti than over Darwin, then you have at least the active phase of the MJO, and if it stays active long enough, you get El Nino. El Nino is effectively like a super long-running active phase of the MJO. So the daily contribution is negative. That suggests that we're in the active phase of the MJO, and you look back and it goes, it's been negative for a good long time. For almost a month now, since June. And that's a good sign. That means we're in at least the active phase of the MJO. The 30-day average, that takes some of the noise out of it. You say, well, we've been moving from -6 to -13.87. That's good. That sort of looks like El Nino. But you look at the 90-day average. This is the running average. Okay, where were we? We're at -4 a month ago, and now we're at -8.58. Well, that's pretty good. But really, to be in El Nino, this needs to be down about -12 or 15. We're not there. And what we suspect is happening is this is a lot being driven by the active phase of the MJO. We looked at the models. We know that's going to fade out here pretty soon, like in the next 5 days. At that point in time, this index will start going positive. This minus 13 will start moving back towards minus 10 and minus 5 and then to 0. And then at some point, this guy is going to start rising as well. In fact, let's take a look at the average graph. Here we go, the 30-day moving SOI average. Now this is interesting. So here we are today, way negative. This looks like El Nino territory. This is as deep as we've been for, what, 2 years? Or at least a year and a half, January 27, a year. Oh, 2.5 years, excuse me. All right, so this was our weak El Nino in here, and we're actually lower than that. You go, my gosh, we're heading towards El Nino. It certainly looks like it. Well, we know from other data that that just isn't going to happen. So each one of these downward pushes is the active phase of the MJO, and it's been steadily nickeling and diming us down. But when you have this and you don't have significant amounts of warm water in the East Pacific, there's just no way you're going to get El Nino. And it seems like in the West Pacific, whatever warm water there is getting tapped out. So we'll see. We suspect this is a false flag. The one thing we didn't show was sea surface temperature. We looked at the picture, the images, but we didn't look at actual values. So here we go, Nino 1.2 region. This is the area right up there along the Galapagos off of Peru. Current temperatures minus 0.892, almost a degree below normal. Now this is a noisy area, but you can kind of see even since April, temperatures, yeah, they've been warm at times, but by and large, the trend is heading downward here. And then in the Nino 3.4 region, this is the official El Nino monitoring region. The values today, 0.353 above normal. All right, El Nino starts at a ½ degree above normal. It needs to be there for 5 consecutive months. We fell below that threshold back in about June 20th or 21st, something like that. And we've been trying to recover, but the index hasn't. And the trend, if you look here, if you just draw a line through this, it's steadily heading down. This very much smells like the end of our weak El Nino. And then finally, the forecast for temperatures in the Nino 3.4 region, the official El Nino monitoring region. Well, you need warm water to get El Nino, and here's where the model's starting off like July 4th or so, and the trend is not positive, negative. The good news is not too negative, down to a ½ degree below normal, and sitting there, what is that, September, October, November, December, into January, and then starting to rebound. So probably not enough to qualify for La Nina, but maybe, and just barely a minimal La Nina at best. So again, we don't think this will manifest or really stomp on the atmosphere too much till we get into about this time range, the December-ish time frame. But still, probably not a strong signal for a great, winter surf season, and probably not a good signal for a lot of precipitation, especially considering last year was a pretty solid precipitation year. Now, not off the charts. Actually, if you look at the numbers, rain-wise in the central California area, it was about typically normal. In Northern California, it was a bit above normal. Snowfall amounts were about 140% of normal, 150 in the Tahoe area down into Mammoth. So it did better snow-wise than in terms of actual rainfall. Maybe that's because air temperatures were cooler, so it just wrung more snow out of the atmosphere. Anyway, this winter, probably not as encouraging as last winter was. All right, to wrap things up, swell is in the water right now. Nothing huge, but there is rideable southern hemi swell for California. The final swell of the run, and it's been, a 4 or 5 swell run, so it's been a good couple of weeks. Final swell hitting Hawaii now. They're getting solid overhead surf at select breaks there. That is coming to California for the coming work week. After that, things go pretty quiet. Wind swell to be the best hope. Looking long term, in terms of the MJO, moving to the inactive phase, probably no significant surf other than wind swell for the next 3 to 4 weeks beyond that. After that, El Nino dying, moving towards maybe a minimal La Nina, so probably a slightly suppressed winter after that. Anyway, that's our forecast for this week. If you've enjoyed the forecast, look down here over on the right. There's a button. You can hit the thumbs up button if you like it, or hit the thumbs down if you didn't like it. Comments always welcome, and you can subscribe. There's a subscribe button down there and a little bell. You click those, and when we post new forecasts, you'll get notified right to your email, and then you can watch the video. Thank you for watching. We'll do this again next week, same time, same channel.